last video we are actually discussing about the question number 4, 5 and 6. So now we come to the section B, question 7 and 8. 7a, a cylinder with a volume V have a radius R and height H is inscribed in a sphere of 3m. What is inscribed? Inscribed means that the cylinder, the edge of a cylinder is actually precisely touch on the internal surface of the sphere. There is a meaning of inscribed. So this is same as what I mentioned in my introduction video. We need to interpret, we need to understand what is actually hint by the NPM. So the terms is inscribed means touch at the internal surface of a sphere. If you don't understand the meaning of inscribed, the cylinder might be not touching the internal surface of the sphere. It will cause you a lot of difficulties because there's so many unknown variables inside, including your R, including your H, including your V. So that's the point. We need to know the meaning of inscribed. 7a, express V in terms of R. 7b, find the value of H and R when V is maximum. So when we know that the thing is the maximum, it means that the dV, maybe dr, okay. Why I say maybe? Because we are using this result. We are using this result. Express the V in terms of R. As I mentioned before, there's a hint provided by NPM. So find the value of H and R when V is maximum, which means that when dV dr equals to 0. When dV dr equals to 0. So means that V is no longer having any change. That's why dV dr equals to 0. Maximum, minimum means no longer having any change. Please bear in mind. So hence calculate the maximum values of the cylinder. 7c, describe what happens to the cylinder when R equals to 0 and R equals to 3. D, sketch the graph of V against R. Okay, so you can see that question 7a, b and c is actually served to the question 7d. What we are doing, all of this is actually for us to plot the 7d correctly, to prove that 7d can be verified. So we come to the 7a first. Express the V in terms of R. We must use the Pythagoras theorem. We use the Pythagoras theorem. We took the lower part of our sphere. You see, from the central point of this sphere up to the touching edge of the cylinder to the internal surface of the sphere is actually the radius, the length of the radius, and we know that the length of a radius is 3 meters. So this thing is actually the radius of what? Of sphere. Okay. So, and we know that this thing up to the bottom of the cylinder is actually half of the height of the cylinder. Do you agree that? This is actually the half of the height of a cylinder. Because this one inscribed, so the bottom of the cylinder can't be touched on the bottom of a sphere. So when we obtain this thing, what else can we obtain? We also know that in this circle surface there is the radius of our cylinder, the smaller r. This is the radius of our cylinder. So doing the Pythagoras theorem, 3 squared equals to h squared over 4 plus r squared. That's how we obtain this thing. However, when we square root both sides, the h is actually equals to plus 36 minus 4r squared, where negative doesn't exist because we know that the length cannot be negative. There's the disobey of the physics law. So V equals to pi r square h, this is the cylinder volume, and then we do the differentiation, we obtain the dVdr. So this is our dVdr. This is our dVdr. I am actually using the u prime v plus v prime u. This is the multiplication rules of our derivative. So when v is maximum, dVdr equals to 0. What can we obtain? What can we obtain? We are actually obtain these terms. But before entering that, I'm going to explain what is the maximum, the concept of a global maximum, global minimum. First thing first. Global maximum means that in the whole curve of your functions, it is the most highest point of your whole curve. It means global maximum. Global minimum is another way around. It's the lowest point in your whole curve. Local maximum and local minimum means within a certain range, it is the highest point. It is relatively highest point within a certain range. Vice versa, in a certain range, it is a lowest point, what we call as a local maxima, local minima. I use maxima, maximum, minima, minimum is for singular and plural terms. So when we talk about global maximum, we know that the global maximum is only one. It can't be many. Global minimum only one. It can't be many. So I will use global maximum. If local, I will use local maxima, local minima. So that's the difference. So when we know that when the slope is increasing, is the dVdr is greater than 0, decreasing, the dVdr is smaller than 0, and when the slope doesn't change, means dVdr equals to 0. This is what I mentioned just now. And this thing is also the same. So you need to understand when does it increase, when does it decrease. It means positive of your dVdr, negative of your dVdr. Hence, we can obtain this one. We let the term just now we differentiate e equals to 0. We let it equals to 0. Yeah. And then we will obtain this one r. So you must remember lah. You must remember there is no negative for physics dimensions for r and h. So we substitute inside the value of r and h, we obtain the v. This is the maximum of our cylindrical volume. Okay, this is what I mentioned just now, the dimensions error. Okay. So question number 8. The rate of change of a percentage of a population of the black beetles with respect to time t is given by dy dt equals to k multiplied by 2 minus 3y plus y squared. Where y is the percentage of a population of the black beetles. Initially, means when t equals to 0, when time started, 50% of the population, 50% means y equals to 0.5, is black beetles. Research shows that in the 4th year, t is in years terms, so t equals to 4 at here. The population of a black beetles increases to 80%, means y equals to 0.8. So we have two sets of data. One is t equals to 0, y equals to 0.5. One is t equals to 4, y equals to 0.8. First, we must find the value of k, hence obtain a relationship between the y and t. How we obtain the k? First thing first, integrate both sides, because this is the chapter of the differential equations. Bear in mind, you must know when the question is asking, you see the time t, you must know where does it from. If you apply chain rule inside, you apply dy dx equals to dy dt times dt dx, it wouldn't work, because this is come from the differential equations chapter. So you must integrate both sides. Bring this thing to bring this thing to here, bring this whole y thing to your left hand side, and then integrate both sides. So you can obtain a equation and substitute the readings here. You will obtain the k. Determine the percentage of the black beetles in the year number 10. Will the population of black beetles reach 100%? Give your reason. So this is the mathematical reasoning. Then they need to examine you really understand about the questions. So we apply differential equations. We put all y on our left hand side, all y's at here, all t at our right hand side. Since there's no t, so we left k there. So integrate both sides by in terms of dy and in terms of dt. We will get this thing. Ln y minus 2 divided by y minus 1 equals to kt plus a. However, how did I get from here to here? I using the partial fractions method. So when you know that there is a with different root of the equations at here, different root y equals to 2, y equals to 1, we can split there into this form. It's easier for us to do the integration. Okay, it's easier for us to do the integration. You must bear in mind how to use the partial fractions and how to integrate by parts. This is massively used techniques of integrations. So we substitute t equals to 0, y equals to 0.5 inside this formula. Because what? Because we need to obtain a. We need to obtain a. And when t equals to 0, we can ignore coefficient k. So we obtain the a. A is actually our unknown constant when we do the integration, because this one is the indefinite integration, so there is an unknown coefficient there. You can use any capital letters as you like, not must be C. Okay, so we substitute another sets of value, t equals to 4, y equals to 0.8. Now we can obtain the k. You may be wonder why don't I substitute this thing first and this thing later? Because I need to solve for a first, then only I can solve for k. You can do another way round, but you need to do the simultaneous equation again. So this is the I obtain the value of k at here, and then I obtain the y in terms of t. I just rearrange. I exponent this thing to here, and then I rearrange the y, because you might remember this is actually our y. So there are two methods to prove that y equals to 100%. First, we let y equals to 1, because 1 is equals to 100%. Second, we let t approaches to infinity to check the populations of beetles. Do you remember C? We need to check the population of black beetles, and we need to do the mathematical reasoning. We're referring to the method 1. You can find that we are failed to prove that y equals to 1, because when we substitute y equals to 1, this thing becomes infinity. This thing becomes ln negative 1. So none of these are valid. So y is impossible to be 1. How about another method? Which means in the infinity of time, will the population of beetles grow to the 100% of that populations? We substitute infinity inside. We know that exponent power of an infinity, we will get back the infinity. So means that even in the infinity of time, y still cannot be 1. It still cannot be undefined. So we cannot say that the black beetles can breed to 100% of its population in the habitat. So that's all for the 2020 semester 2 STPM XT questions.